Hey guys, today I'm going to give a demonstration of a project that I made in Java. So this is basically a smart agriculture management system which I made in Java based on object-oriented programming principles. So I'll start with the project, the explanation. So first of all, this is the main folder, Smart Agriculture Management System. So in this we have this SRC. This contains all the utility classes and all the folders, subfolders which contain all the Java files to carry out the tasks. And then this app.java, that is the main app that runs all the simulation and also calls all the other helper functions and helper classes to start the system. So that is it. And these are the basically images of how this project works. So I can just show you. I'll open file logs. So this is what my project does. What it basically does is, it first of all asks the user, like the admin, to set the minimum threshold of four different parameters of the farm. First is humidity, second is light intensity, and then soil moisture, and then temperature. So if the value of these four parameters cross these limits, like if the humidity goes below 30% or is below 40 or above 40%, then there will be machines that will be automatically activated and they will bring the value down to the nominal value. So that is what my project does. So you can see here, it what it does is it generates a random value every 15 minutes, and based on that, the sensors, I've made sensors classes, the sensors analyze the data and they check it with the threshold values. If it is violated the threshold values, then the machines get activated. Like the hygrometer measures the humidity value, and if it is violated, the humidifier will get activated or the dehumidifier will get activated. I'll explain you, and I'll also show you the files that I've made, the class files, the Java codes that I've written for them. And then there's a okay, I'm sorry, yeah. So there's a user file also that logs all the users. So there are basically three types of users. First is admin, who will set all the threshold values and who will have the control over the entire system. And then there will be agronomist, who will be examining the data, the crop health and different parameters, and he'll be taking out actions. He will be responsible for operating manual machines as well. And then there will be farmer, who will be carrying out those actions like starting irrigation or turning the drain pipe on or off. I'll show you all those things. And then there is this actuator activities.txt. So what this file does is, it tells at what time what machine was turned on and at what time that machine was turned off, and it also calculates the charge for that machine per hour, and it gives the total money spent for the day after 24 hours of simulation. So yeah, that's it. That's what my project does. So I'll start with let's suppose, okay, I'll open SRC. So I'll first discuss this secure authentication. So I'll just close this. Yeah, also I forgot to show you. What my program does is, it also logs the data values to an Excel file, and in the Excel file we can plot these values on a graph, and this is how the graph looks. This is for a particular simulation. So you can see here, I set the humidity. So this, okay, let me just adjust this. Yeah, so I set the humidity to I think around 45 to 55. So you can see here, the humidity was uh, almost near to 100%. So it was brought down probably by the dehumidifier, and then it was stabilized around this value. So this is what the simulation does. When the random values are generated, it tries to stabilize this value. Temperature was stabilized around 80%. Around this is what, yeah, soil moisture was stabilized around 80 degrees Celsius, and the temperature was stabilized around 20 degrees Celsius. So this is what the program does, and it is a very realistic simulation. It's not like it just generates random values and tries to stabilize it. I'll just show you the simulation, and then you'll realize that the simulation is very, very real. And I've tried to keep it as realistic as possible. I'll show you the simulation, and then this is the light intensity data. So this is what my program does. It logs it on the text files and also logs it on the Excel file. So yeah, so let's start. So I'll start with secure authentication. So I'll just close app.java. So in secure authentication, I have authentication.java and encryptor.java, and then some authentication exceptions. So I'll start with okay. So first, let's discuss about authentication exceptions. So these are some custom exceptions that I've made, and I've inherited these custom exceptions from the exception class. So these are like incorrect password exception, invalid name exception, invalid username exception, invalid user type exception, and then user does not exist exception, weak password exception. So I'll explain you these, like you'll get to know about these better when we discuss about authentication. So let's open authentication.java. So this authentication.java is mainly responsible for sign in and sign up of users in the system. So the main functions that I've made here is this one, the sign up function, and then I have this sign in function, and then log all details of users to the text file, and then some utility functions. So I'll start. So what happens is this authentication class is an interface. I've made it as an interface. Uh, and then what I do is I have this array of users, which is basically of type person. I'll discuss this type, the class person. So I'm saying that there will be at max 100 users of this management system. And then there are three types of users: admin, agronomist, and farmer. So although it's public, I could have made it private. I think it would be a better idea. Yeah, anyways, so first of all, this is does username exist. So this function just checks that in the database if the particular user with the username exists or not. And then after that, there is check valid username. So it checks if the username entered by the user is valid or not based on these four conditions: the letters, the numbers, and then hyphen, underscore, and then period should be there, and the username should not start with period. So it checks these conditions. And then it checks valid name. So the name is valid only if it has letters and no numbers. It can have only letters and spaces. So it checks that. After that, I check the password strength. So these are the conditions: that there must be at least eight characters, at least a small letter, at least a capital letter, at least one digit, and at least one special character. So this function checks that. And if it is not meeting these requirements, it throws this weak password exception. And here also this throws invalid name exception, and this throws invalid username exception. And then after that, if I go with sign up, so this is what the sign up will do. It will ask the user first of all to enter the type of user they want to register. That is, if they want to register as an admin, as an agronomist, or as a farmer. And then if the user enters some other number, maybe greater than 2, it will throw invalid user type exception. And then it also asks for full name. Enter your full name, so you can enter that. And then it will ask for creating a new username. It will also list out the invalid username exception conditions, so that the username always enters, so that the user always enters a valid username. And then it will check if the username is already existing in the database. If it exists, it will ask the user to again enter a new username, and then create a password, and it will list out the weak password conditions. And then it will store that it will check the password strength. And then after that, it will ask to enter the phone number to the user, and then it will store the user phone number. After that, it will create an admin, an agronomist, or a farmer of person type. I'll discuss these classes as well: person, admin, agronomist, and farmer. And then it will store the person in the database. And then there is sign in function that helps the user to sign in. So what we can do is, it will ask for the username first of all. It will check if the username exists or not, and then it will if the username is not existing, the does username exist will return null. So if it is null, that simply means throw user does not exist exception. And then it will ask the user for entering the password, and it will also use console input.read password. So this will not echo the characters on the terminal. So this is just basically a uh, privacy handling. And then after that, it will check the password is matching or not. And if the password is matching, then it will return the person, the sign in function. Otherwise, it will return an incorrect password exception. And then log all details of users. This this function, what it does is, it logs all the details of the user to a text file. So this is the location, src data logs, users data, and users data.txt. So it's here data logs, uh, users data, and users data.txt. So it logs all the users to that place. So yeah, that's it. And then there are some other abstract functions that need to be implemented by users admin. So it is update password of user and delete user. So authentication is an interface, and in the admin class there are two nested classes. I'll show you. So one nested class, which is users admin, will be extending this, implementing this authentication, and it will be implementing these two abstract functions, update password and delete user. So now I'll go to person, this encrypted.java. Okay, let's discuss encrypted.java. So yeah, that's it, encrypted.java. So here what it does is, basically I'm not storing the password directly in the form of a string. Rather, I'm storing it in a hashed form, so that even if the database is compromised, or even if it is under attack or risk, then the password should not get leaked. So this encryptor makes sure that the password is always hashed. So here I have used a very simple encrypting algorithm, although it is not recommended to use it. But since it's just a simulation, I can just demonstrate it by my own algorithm. Although it's better to use some library or something to encrypt the password. So yeah, so the hashing algorithm is very simple. First of all, the password is reversed, and then from the 0th index of the reversed password is string. The characters ASCII values and their index number is hashed in a hashed password array. So this hash password uh, function basically does that. It takes the password string, hashes it, and returns an array of integers, which is the hashed password. And then after that, there is a is password match function in the encryptor class. What it does is, it first of all takes the person and then asks from the person the hashed password, and it decrypts that password, and then it tries to uh, check that if the password entered by the user, this entered password is matching with the person's real password or not. If it is matching, it will return true, otherwise it will return false. So this is what the encryptor class does. So that's it. So let's now discuss secure authentication is done, right? Now we will go to users. So in the users, I have first of all the person abstract class. So in the person's abstract class, I have these data members, name, username, account type. Account type is basically either admin, agronomist, or farmer. And then I have hashed password, phone number, and salary. Now if I see here, this is the constructor for the person, and this person is an abstract class, and it will be inherited by, like, the admin, the agronomist, and the farmer classes will inherit the person class. And then there are some helper functions, like some getter setter functions. First of all, there is this utility function, is password match or not. So it will call encryptor class, it will call encryptor classes is password match method, and it will check if the entered password is matching with the user's real password or not. And then this get hashed password, this will basically uh, return the hashed password of the person. Get phone number, get salary, update password, it will update the password of this person to the new password, and then it will update the phone number. So these are the simple utility and getter functions of the person abstract class. Now let's discuss about admin. So admin is the person who will be responsible for taking all the decisions in the agriculture management system. So what I have done here is that the admin class extends the person, and then in the admin class I have defined two nested classes. The first one is users admin, which will implement authentication, and then there is field admin, who will be responsible for taking all the threshold values, who will be deciding all these threshold values. So first of all, I have admin who extends the person, and then here a simple constructor overloading. Here I'm passing a salary, or if I'm not passing a salary, by default the salary of the admin will be 1 lakh rupees. And then the nested class users admin, the users admin will implement authentication. So the authentication will be update password of a user or delete a user. So update password is simple. First of all, it will ask the person to log in whose password needs to be updated, and then it will say create a new password, and then it will update the password of that person. So that is what this function does. After that, there is delete users. So first of all, it will ask to sign in with the user whose account is to be deleted, and then it will check it in the database. It will, if it is found, first of all it will log in that person to the database, and if it is found, it will delete the user, and then it will remove that user from the database. So this is what this function simply does. And then there is a nested inner class, another one, which is the field admin and admin of the farm, and he takes all the farm related actions. So these are the how many values are there? 8, right? Yeah. So for 4 parameters, we have 8 threshold values, minimum and maximum. So for humidity, I have these values, and then for soil moisture, light intensity, and temperature. So I've by default set these values to some random values, although these will be decided by the field admin. I'll show you how it will ask for setting the threshold values. So yeah, so this means that if the humidity falls below this value, then the humidifier will get activated, and maximum humidity threshold means that if the humidity falls goes above this value, then the dehumidifier will get activated. So yeah, these are the threshold values, and these are the setup functions for these threshold values. And yeah, that's it. That's what the field admin does. So secure authentication is done, users is done. Now we will move to, let's suppose we can move to field meters. So in the field meters, I have meters, and then I have farm simulator and sensor.java. So let's first of all discuss about sensor.java. Okay, so what I'm saying is that any particular meter, like a hygrometer, a thermometer, a photometer, or a soil moisture meter, all these machines, all these meters are made up of two main parts, right? The first one is the sensor, and the other one is the data logger. So that is what I have done here. I have made a sensor.java and a data logger.java, and all my 4 meters, hygrometer, photometer, soil moisture meter, and thermometer, all these meters implement both of these interfaces, sensor and data logger. So here I have done multiple inheritance. So first of all, I'll move to sensor. So in the sensor, I've made it an interface so that multiple inheritance is possible, because we know that multiple inheritance is possible only if the parent class is an interface. So I've created an interface. Manufacturer is I'm saying that it's any random company, Mitsubishi or any other company, we can give it the name. And then I'm saying that the sensor's lifespan is 1 year, 365 days. And then I'm saying that there are two abstract functions to be implemented, sense data and send data. And then in the data logger, I have similarly manufacturer and lifespan, and I have two functions to be implemented, receive data and log data. And now my meters will implement these two interfaces, sensor and data logger, multiple inheritance. So first of all, this hygrometer will have a data that it will sense. So what it will do is, first of all, it will sense the data. So transducer, that is basically the sensing element of the sensor. The transducer senses the data and sends it to the sensor. So now sensor will receive the data from the transducer and send it to the data logger. And then the data logger will receive the data from the sensed data from the sensor and logs it to the display. And now in the log data, what will happen is it will call the meter logger utility class function. I'll just explain this: log humidity and log time, all these things. It will log it on the text file, and it will also send it to the agronomist for analysis, and it will also instruct the humidifier and the dehumidifier to read and analyze the humidity data. So this is just basically the simulation of any particular meter. Like, it will, first of all, it will sense the data, the sensor will sense the data, and then it will send it to the data logger. The data logger will display the data, and it will send it to the agronomist for analysis, and it will also call the dehumidifier and the humidifier to read the data and take out the actions. So yeah, that's a simple simulation that I've done here. So hygrometer, photometer does the same thing, senses data, receives data, and then sends data, logs data. Soil moisture, same thing, entirely same, and the thermometer also. So it's just like hygrometer measures humidity, photometer measures light intensity, soil moisture meter measures soil moisture, and thermometer measures temperature. So these are my meters classes. And also I have done one thing. I have made two actions as automatic and two actions as manual. So I'm saying that my humidity and my temperature, these will be automatically handled by the humidifier, the dehumidifier, and the exhaust fans and the heater. While on the other hand, the light intensity and the soil moisture, these will be set like these will be controlled by the agronomist. So agronomist will analyze the data and he will tell the farmer to take out the manual actions, while on the other hand the humidity and the temperature will be automatically handled by the automatic machines. This is what I've done. So now I'll open farm simulator. So this is the main core logic that generates random value, realistic value, and it also checks if there is an effect of any particular machine or not. Okay, so first of all, I'll start with let's start with farm simulator. Okay, so farm simulator, and then this is a private static final delay in milliseconds. So it will produce data in every delay milliseconds time. So this is set to 200 right now, so I'll just set it to 1 second. Okay, so that we can see what actually is happening. So this is 1 second, set to 1 second. Now after that I have some data members here. The humidity value, it will generate a realistic value for humidity, light intensity, soil moisture, temperature. And then there is a compound humidifier effect, dehumidifier effect, heater, exhaust fan. So what are all these values? I'll explain you. See, first of all, we know that if there is a particular machine operating over a period of time, then its effect will get compounded, right? So I'll explain you with an example. So let's suppose that you're sitting in a room. So if the heater is switched on, in the first maybe 1 hour, it will increase the temperature of the room by, let's suppose, 1 degree Celsius. Then in the second hour it will increase by 2 degrees Celsius, and then in the third hour it will increase by 3 degrees Celsius. Now after, let's suppose, 3 hours we switched off the heater, then its effect will reduce, right? The temperature will fall gradually from 3, like the fall will be from 3 degree, then 2 degree, and then 1 degree, right? So this is what this these values hold. They hold the compound effect of these machines: the humidifier, the dehumidifier, heater, exhaust fan, irrigation pipe, irrigation pump, and drain pipe. So they calculate the compound effect of these machines. Now here I have said that there can be 3 types of weather conditions. Just the simulation: sunny, dry, cold, rainy, and hot, humid. And this start function is there, which will start the farm simulation. So first of all, I set the weather of the current day. So it will be cold, rainy. It is set to cold, rainy right now, so I can just set it to maybe sunny, dry, right? Then after that I can go to string actuator path, log path. Okay, so before that I'll just pause here and I'll explain you the data loggers. Where is it? Yeah, loggers: actuator logger and meter logger. So what these classes are doing is that they are simply opening up the file, the actuator activities.txt, so that all the actuators can call this class to log their data on the actuator activities.txt. Similarly, meter logger is also opening the file, the text file and the Excel file, so that all the meters can log their data. So these are just helper classes that will open up the file one time, and then after the end of the simulation they'll close the file. So I'm not going into the deep detail of it. It's just logging the time, temperature, humidity, light, and soil moisture value to the text files, and yeah, that's it. And it's also logging it to the Excel sheet. The meter logger and the actuator logger is also doing the same thing. It is basically logging all the actuator activities to the actuator activities.txt file. So yeah, that's it. So that is basically initializing these actuator logger and meter logger. This part is doing, and then I'm creating new instances for all my 4 machines: hygrometer, all my 4 meters: hygrometer, photometer, soil moisture meter, and thermometer. Now I'm starting the simulation for 24 hours of a day, and I'm saying that every 15 minutes it will generate a random value, and it will be realistic. I'll show you. And then after that it is formatting the time into hour and minute, and then it will call the generate realistic data function to generate a realistic data value for the particular time of the current day. And then the hygrometer, photometer, soil moisture meter, and thermometer will sense their data, and they will like the transducer will sense the data, and then it will send it and data log and all those things. And then it will just pause for the delay millisecond time or unit of time, so that we can see what actually is happening. So it's basically like 15 minutes of a day is equivalent to delay ms. And then after that, after the simulation is done, it will say simulation completed for 24 hours, and it will also calculate the total cost that was accounted for the particular day. And then it will close the file loggers classes. Yeah, that's it. Now I'll discuss the generate realistic data function. So what it does is, first of all, uh, it creates a simulation of everything. So if I talk about light, how does light change in a particular day? So in the morning, the light, obviously light intensity is 0, and then it goes in the noon, and then it goes down again in the evening, and then remains 0 till the next morning, right? So this is what it is doing. So it's basically a sine function, right? So the light method is basically following a sine curve, and here I'm also defining the maximum and minimum light intensity. It can be 60,000 in a day or 15,000 in a day. So this is just simulating it. And to be honest, I've not written this code on my own. I took help from ChatGPT for this. So yeah, that's it. Just generating realistic random values for these. So that's why I did this. And then after that, it will see that if the shade is active, then it will add the effect of shade, or it will add the effect of sodium lamp if they are active. So that is what it is doing. And then finally, the light intensity will be cut from negative to 0, and then whatever the value is. So it's like light intensity can never be negative, right? So that's it. That's what it is doing. And then after that, temperature and humidity. So I'm saying that so what I'm doing is, whenever I'm generating a random value, I'm adding a random noise to it. So let's suppose the generated temperature is 17 degrees Celsius. It will add maybe 0.3, 0.4 plus minus noise to it to make it realistic. And then for cold rainy day, I'll have base temperature of 15, and temperature can vary by 3 degrees, and humidity base can be 90, because obviously in a rainy day humidity will be more. And then the humidity can vary by 5. So that is what I've defined different classes. Not me, actually. Actually ChatGPT has done it. So yeah, it has defined some noise and base values for it. And then after that, I have compound heater effect. So whenever I'm calculating the final temperature data, I am always including the compound exhaust fan effect and compound heater effect. And I'm also updating the compound heater effect and compound, like, see, what is happening is that any value either increases the parameter or decreases the parameter. For example, humidifier will increase humidity and dehumidifier will decrease humidity. So in the way their effect will be compounded, that will be different. So I've made these helper functions which simulate this thing. So yeah, that's it. And the temperature value includes the compound effects of both the machines. And then similarly, humidity also includes the effect of both the machines, and then it cuts humidity to 0%, between 0% and 100%. And then soil moisture, again, basic simulation that on a cold rainy day soil moisture will be more, in a sunny dry day soil moisture will be less, evaporation rate will be more. So this is just simulation, not much of not much of object oriented programming approach here, just simulation. And then adding to soil moisture the compound irrigation effect and drain pipe effect, and then cutting off these values between 0% and 100%. And then this is the update compounder effect that decreases the parameter, and this is update compound effect where of the machine that increases the parameter. This is this helper functions. And it is also calculating the total cost. So it is, this farm simulator is sending the total cost data to the field admin. Each time a particular machine is activated, it will include its cost. So the cost is in per hour. So for 15 minutes it will be cost by 4, right? That's it. So yeah, this is the farm simulator class, very rigorously written and always generates a very realistic value. So that is it, farm simulator, that's done. Now we will move to actuators. Yeah, we'll move to actuators. So all these things are done, we'll move to actuators. So I have two types of actuators, automatic and manual. In automatic I have dehumidifier, exhaust fan, heater and humidifier. And in manual actuators, I have drain pipe, irrigation pump, shade, and sodium lamp. So dehumidifier and humidifier will control humidity, exhaust fan and heater will control temperature, drain pipe and irrigation pump will control soil moisture, and shade and sodium lamp will control light intensity. So dehumidifier, first of all, it will have a data member of effect, that is that dehumidifier will change humidity by what value. It will be by -2% per 15 minutes. And then there will be operation charges for dehumidifier, that is basically in per hour. And then there is a switch, like there is a status if the machine is active or not, so that the farm simulator can include its effect in the generation of the data. And then after that I have a manual switch. If it is -1, that means the machine is turned on, so it will be all, sorry, if the value is -1, that means the machine is turned off and it will be off forever. And if the machine is set to 1, that means that the machine is always turned on irrespective of the values that it is sensing. And then after that, if it is 0, it is set to automatic to operate automatically. So this is the read and analyze data. So this is just simple. If the value is nominal, if it is within the range, do not do anything, turn off the modifier, dehumidifier, and return. Otherwise, if it is more than the maximum threshold, dehumidifier will be turned on and humidifier will be turned off. And yeah, that is a turn on and turn off function, and then log it to the text file. Similarly, all these things, their effect, operation charges, active or not, flag, and then read and analyze temperature data. All these things are the same way. Compare it with the threshold. If it is within the range, turn it off. If it is not, turn it on. That is what these functions are doing. So they all are similar, very similar. And I also forgot to just show you the agronomist and farmer, right? So I'll open agronomist. So what it does is, agronomist will read and analyze humidity data, temperature data, light intensity data, and soil moisture data. So these two parameters will be automatically handled, so the agronomist does not have much to do here. But here the light intensity data and soil moisture data, he has to do it. It is not automatic. So for manual action, he is instructing the farmer to turn the sodium lamps off or to remove the shade based on the light intensity value, like its position with respect to the threshold values. And similarly here also, for controlling the soil moisture, he is telling the farmer to stop irrigation or close drain pipe based on the soil moisture's position with respect to the threshold values. And then the farmer is carrying out these actions. He's starting the irrigation pump, he's turning on or off the drain pipe, he's turning on or off, like covering with shade or not the field, and then turning on or off the sodium lamp. So yeah, that is it. So this is users, agronomist done, secure authentication done. Loggers I've told you already that these basically are for logging, for opening the text files and logging the data, so that all the meters and loggers can call them, the meters and actuators can call them. Field meters I've already discussed. There are 4 kinds of meters, and then farm simulator that generates realistic random values. And then actuators is done. Now data logs. So data logs is the folder that contains all the data logs. So actuator activities, it will contain it in a text file. So this is how it will look like. This is basically the data of the previous run. And then at the end, it will also show the total amount of money spent in the particular day. Then there will be sensors data. It will have a CSV file which will log all these data to the Excel sheet so that we can draw curves and see the data. And then sensors data, it will just create a table of it. So all the sensors, when they sense the data logger of the particular sensor, the particular meter will log it to a text file. And then users data, this is basically storing the details of the user. So that is it, right? So these 4 numbers are random, so yeah, there's no point of calling them. Yeah, so yeah, that's it. I think we are done. So now I can start the simulation and show you how things are working here, right? So what I've done here is that I have opened up the command cmd prompt, and then I have my text files here, the users data, so these are the values of the previous run, right? So I'll just start it. First of all, what I'll do is I'll compile all the class files. So that's the command line for this. So once my all class files get compiled, I'll start the simulation. Oh, I forgot to show you the app.java. So app.java, what it is doing is it's basically starting the system, and then it is asking to create users account, field admin account, agronomist account, farmer account, and then it will say all accounts created. It will ask the users to admin, sorry, it will ask the admin user to log in, and then it will take out the decisions that if the user's admin wants to delete a user or update the password of a person, and then it will ask the agronomist to log in, the farmer to log in, and then it will ask the field admin to set the threshold values, and then after that it will log all the users to the text file, and then it will start the simulation and the farm simulator will start. So that's what the app.java does. So now let's open and I'll see. What I'll do is java c app.java, compile the java. Okay, now I'll start the app. So it will say, first of all, enter the type of user you want to register. So I want to create a user's admin account, so I'll say admin. Okay, now it will say enter a full name. So let's suppose I enter any particular name, Mars Khan. Now it will ask username mars.i7, password mars at 123. Let's suppose password here is random and the password will not be echoed here. Now phone number 1 2 3 4 5 6 7 8 9 10, and then field admin. So let's suppose admin again, right? Full name, so let's suppose I enter any name, maybe David Paul. Okay. Username, so let's suppose David dot d dot 26. Password David at 123. Phone number any random 1 2 3 4 5 6 7 8 9 10. Now it will say create agronomist account. So I'll say okay, agronomist account. Let's suppose full name. So let's say John Paul again, and then username, so john.26. This will be the username, right? Password will be again john at 123. Phone number 1 2 3 4 5 6 7 8 9 10. And then type of user farmer I want to register, so I'll say farmer. Let's suppose Carl John or Carl Paul, whatever. And then username Carl.26. Password again Carl at 123. Now it will ask for phone numbers, so 1 2 3 4 5 6 7 8 9 10. And then it will say the admin to log in. So I was the admin, so I'll log in. So it is what? It is user's admin. So I was the user's admin, so mars.i7. Password, I'll enter my password, mars at 123. It says that they want to delete a user, so right now I'm just skipping it, so I'll say no. Then it's asked if you want to update a password or not, so I'll say no. And then agronomist will log in. So who was the agronomist? Let me check. The agronomist was John, right? Agronomist John.26. Okay, so John.26. Password was John at 123. Now it will ask the farmer to log in. So I think farmer was Carl, right? Yeah, so Carl.26. Password Carl at 123. It will ask the field admin to log in. So who was the field admin? I think it was Joseph, or what was the name? I forgot. Just check. David. Okay, David. So David.26. Password was again David at 123. Now it will ask the field admin, that is David, to enter the minimum threshold value. So let's suppose that I don't want the humidity to fall below let's suppose 30, and I do not want the humidity to go above 40. And then it asks to input the threshold for light intensity. So let's suppose that I don't want the light intensity to fall below maybe 5000 or something, yeah, and 5000 lumens. And then maximum will be, let's suppose I don't want it to cross 10,000, so I'll enter that 10,000, right? After that, it will ask for soil moisture. So let's suppose that I don't want the soil moisture to fall below 40%, and I don't want it to go above 80%, let's suppose. Okay. And then temperature, I don't want it to fall below 20, and I don't want it to go above let's suppose 30. Okay. Now it will start the simulation. It logged all the data of the users to this file. Simulation has started. It is generating random values, and based on these values, the machines are getting automatically activated or deactivated, or the farmer is doing that. So that is it. The values are being generated, and it is logging all the details. So this is basically the timestamp. The first column is for temperature, second is for humidity, third is for light, and then fourth is for soil moisture. And based on that, it is also telling what all is being done with the timestamp. So right now it is 8:45 in the morning, 9 a.m. So you can see here the temperature is first of all, getting stabilized between 20 to 30, almost between 20 to 30. And then you can see here the humidity is also being stabilized to between 30 and 40. Light intensity, although it is going 50,000, because obviously the shade can reduce it by a particular value only, and I think I've set it to 10,000. So obviously it's generating realistic data. After that, soil moisture, this is what this is soil moisture. So soil moisture is almost trying to be stabilized between 20 to 30, 40 and 80. So yeah, soil moisture is getting stabilized here, right? So this is for soil moisture and all. So I'll show you the graph, then that will be more clear to you what's actually is happening here. So let's wait for the simulation to end. The first column is for temperature, right? So simulation is done. So now it is saying that total money spent today was 670 rupees, and it says that simulation completed for 24 hours. Open Smart Agriculture Management System, SRC, data logs, so sensors data, farm data.csv to plot graphs and study the data. So let's open that folder. So this is here, data logs, sensors data, farm.csv. This is it. I'll open it. So these are the values. Let's plot graph, time, temperature, humidity, and soil moisture. For light intensity, I'll plot a different graph because its value fluctuates. So yeah, this is the graph. Let's study it. Let's try to study. I'll open the command prompt here and I'll open it in split. Yeah. So first of all, let's discuss temperature. So what was the threshold that I set? Temperature, I set it to be between 20 and 30. So you can see here the temperature is increasing. It's around 20 and then going 30, and then when it crosses 30 it goes down, and then again it goes to 20. And then it is also following that route that during the daytime the temperature will be more, and then in the night time the temperature will reduce. So you can see here the data is very realistic. After that, let's discuss humidity. So I said that humidity should be between 30 to 40%. So earlier the humidity was so much, so it got reduced, and then it came to 40 and then stayed there, little fluctuations here, and then it got below 30, so it increased it so that it remains between 30 and 40, and then again it got increased, then decreased, and then this is it. So this is also a realistic data. And then after that, let's talk about soil moisture. So I said that it should be between 40 and 80. So you can see here the soil moisture is always between 40 and 80. So obviously in the daytime the soil moisture will reduce, so it is reducing. So you can see here the data is very realistic, and it also stabilizes the data. It's not like that it's just increases or decreases. It always tries to keep it within the threshold. And after that, I can plot the light intensity as well. So time, light, insert, plot this. So this is your light intensity graph. Here it is just trying to stabilize the light intensity, and then during the daytime the light intensity will be so much, and then in the night again it will fall and then try to stabilize. So that is it, guys. I hope you liked my project. So this is the project that I tried to make, farm simulation, and then based on the farm's data I tried to take automatic and manual actions by the users, by using the different machines, humidifier and all, and then also simulating the sensors and reading the data from this farm simulator class. So I hope you have enjoyed it, and I have used a lot of hoops concepts here: package management and exception handling, inheritance, multiple inheritance, constructors, method overloading, polymorphism, encapsulation, data abstraction, data hiding, implementation hiding. A lot of things I've implemented here. So I hope you have enjoyed this video and got to learn something from this video. And yeah, if you have any suggestions, you can put it in the comments. Yeah, so that's it. I think I'm done here. So that's it for today. I'll be coming with more videos. So yeah, till then, bye bye.